Next thing we're going to look at is the ZIO ref type. So the ref type is built into ZIO 2, and it is a concurrent mutable reference. And as I note here, it's essentially a container for a value, a mutable value, that can be safely accessed and modified from multiple fibers concurrently. I'll talk more about this mutable part in just a moment. But if you're interested in the details, the ref type is built around the JVM atomic reference type. Atomic operations are lock-free, and the lock-free nature of that comes from using special low-level CPU instructions. As for the mutable part, I spent an awful lot of time talking about how we want our code to look like algebra in equations and blueprints. And then all of a sudden now I start talking about this mutable part. And personally, as I note right here, I got hung up on this for a while for the exact reasons I just mentioned. I like to see my code as algebra, and then all of a sudden we have this mutable reference. And before we go any further, I just want to note that I haven't gone to the dark side. And I should skip forward a couple of slides here and note that the most common use case for a reference is to manage the state of applications, especially in concurrent environments. You don't have to worry about this other stuff yet. Just know that the common use case is to manage state, especially in concurrent environments. And now when you come back to this slide, the way I got over this looks like this. So basically you have an application over here, a ZIO application. And then what you do is you're going to be reading and writing information to and from a data store. And I started thinking, if you have state, I've shown you how to handle that in a single-threaded application with recursion. But then the problem with that is that that doesn't work so well in a concurrent and parallel environment. So I started thinking at this point, okay, what would I do then? And then the logical thing is, well, you're going to store state in some kind of data store over here, and then you're going to be reading from and writing to that data store in the different threads in your application. So the only thing that ref really does is it replaces this need for a data store. So you could think of it as being something like an in-memory data store for state, especially when you're writing code in a parallel and concurrent environment. Okay, so what else can I tell you? Let's go back here for just a moment and reinforce this point. A ref is a container for a mutable value, and it can be safely accessed from multiple fibers concurrently. That's a key point. A second key point is that the most common use case for a ref is to manage the state of applications, especially in a concurrent environment. That's number 2. And now if you look at this slide, ref is effectful, just like everything else we've talked about in ZIO. It's a purely functional description of a mutable reference. And of course that means it's a ZIO type. And therefore all of the operations on ref are effectful. So I think that's a third key point to know. And now if we come back to this key point slide, I mentioned the common use case. Other things to know is that ref is thread safe, and I've mentioned that already. It's a way for us to have shared state in a concurrent environment without having to worry about race conditions or inconsistencies. Then ref is really kind of a low-level tool, and it gives us these atomic operations, and I'll show those in just a moment. But they're simple read and modify and write operations. I already noted some parts about ref being functional in that it's a ZIO type or a ZIO effect. It also provides a functional interface for updates, so instead of directly modifying a value, we use methods, and those methods will take functions to transform the current value. And I already noted this part about it being a ZIO effect, and a key there, as I've mentioned before, is composition. Because it is a ZIO effect, we can compose it, just like everything else that we've composed so far. And then the last point to make about ref is that it has these common operations. So we use make to create a reference. We use get to get the value out of a ref. We use set to set the value. And then update is an interesting one right here. This one is conceptually equal to getting a value and setting it. But if you use get and set, those are actually two different operations. So if you say get the value and then in the next step set the value, someone else may change that value right here. So in terms of code, get and set are not equal to update, but that's what update lets you do is in one operation, get the current value and then set it or reset it. But it's very important to know that if you get the value in one line of code and set it in a second line of code, That's not an atomic operation. And as I mentioned, someone can change the value in between right there. So when you want to perform a get and a set, don't do that. Use update instead. And now, since I went through that explanation, modify now is the safe equivalent of saying get plus set and then get. So you get a value, you set it using some type of function, and then you get the new value when you're done. And all three of these together are considered one operation. So no one else can modify the value while you're working with it right here. So that's an introduction to the ref type. And the next thing we'll do is start looking at some examples.